Hey everyone, welcome to a interview with the BYCOGNITION project. I'm going to let Jacob here take it away in just a second. But yeah, okay, why don't you start? Just tell us a little bit, what is BYCOGNITION? What is this project?
What
are
is
we doing
BYCOGNITION?
here?
Yeah, so BYCOGNITION was a project. I started it, I think it was 2 years ago. It was essentially how can we make a model that works well for science, but also is accessible to more people? So how could you do those two things in one? And that's grown to be encompassing more of the scientific side for BYCOGNITION. So how can we have more foundation and proving what we're actually observing?
Okay. So what we have here in BYCOGNITION is I like to call it a think tank. Basically, that's what we do. We sit around and we puzzle around together, try to solve typology problems. But we have some good members, and everyone brings a different specialty. What's the word there?
Yeah,
everyone brings something really good to the table where no one's really stepping on each other's toes. Good conversation going, and so we're just going to present a little bit of what we've been working on and what we plan to do in the future. So, should I pull up your presentation? We can go through it.
Yeah, sounds good.
Yeah, and then we'll introduce everyone after.
Yeah, so for BYCOGNITION, we're classifying different cognitive processes. So we're trying to, what is the mind doing and how can we express that? So we're going for somewhat below the bottom half of nurture and trying to get more into nature side of it. Yeah. Next slide, please. Wait, can I control the slides?
You can too.
Awesome. So some issues currently around pop psych models is it's hard for people to get into it. Sometimes they have weird terms that makes it hard to start, to begin. And also lots of them don't have as much foundation, as in they're not built on concepts. Lots of concepts have already been well developed, and you can implement those into systems, or at least connect them so that it has somewhat of a, how's this pulling back from all the effort we've already done? The other challenge is closed communities have lots of a siloing effect where the belief of it just becomes true because so many people are doing the same thing. Potential for future models is what's so funny, Lau?
No, I couldn't agree more. Yeah.
For future models, it's a challenge of how can we make these terms less biased. That's always going to be changing as the culture is constantly changing and words have different meanings. But how can we, at least for now, have a clear terms that when they grow, they can have a more founded meaning. But also things that aren't.
On that. Yeah, one of the things about biased terms is even so Jung invented it, he was a type. And so the terms he brought to the table were based on the way he was perceiving it, based on his type. And so unbiased terms is also type free, which is very hard to do.
Yeah. What's something that every single of the proposed different types would agree with for at least a most percentage for their own type? Yeah. Another thing with that is how can you make it, make everything work in reference to each other? And trying to avoid using terms that have been used a lot before. So it's all these different factors are influencing how do we choose good terms. Next one is action towards research. So if you start with more of a foundation to develop the model, hopefully that would bring about a better model. And the other thing is opportunity for contribution. As you have more people being able to contribute in a meaningful way and being able to test things when you have a good foundation, you can grow and improve it a lot faster. So this is our big question. How can we make this single model that contains everything? So I've got some contributors. So you guys know Benjamin. I'm doing management and logistics. I'm a Bachelor of Business. That's what I do. Aziz, you do.
I'd like to step in. Jacob's got a good head too. You got a good head on your shoulders. You're helping with combinatorics. You're doing a lot of other stuff. You're not just doing management and logistics, but we'll let you choose your title, I guess.
Sure. Ajith, you've got AI, cognitive science, and academia side to you. It's awesome to see you do that kind of thing. Rom, you've also doing control system stuff. I'm excited to see what you have to share about that later. And Lau, you're doing some group theory and psychometric stuff. Yeah, we're talking to him. So the BYCOGNITION project a lot of it can be broken down into 4 categories. So building the framework, which is the terminology, the mechanics, which are both connecting the terminology to models, but existing models and researched improvement stuff, but also extrapolating how the different terms interact with each other and form types and such. Academia will be essentially, that's the side where, doing tests and doing articles explaining and building up this academic foundation. An application is transforming all of the other 3 into something that people can start using.
Yeah, right now Ajit is really spearheading the academia side.
So progress, I'd say at the moment is we're getting very close to finishing the framework. I think we've got a good, we've got quite a fair way to still go on mechanics, but we've made a lot of progress. In academia, I think we're just starting to scrape the surface of that. We haven't really hit application yet. So next up, to finish off these top 3 things, is compressing the framework. How can we make it the right size, and just finalizing the last bits. Explain the mechanics, connecting more to existing models, and for academia, expressing the relation to other theories and studies inside of our papers. Yeah, so that's what we're doing at the BYCOGNITION project. Who would like to go after me? For it, Lau?
Yeah, let's go for it, Lau, because Lau might need to jump off.
Okay. Yeah, if you wanted to go off the rails at the beginning, get some viewer attention.
Let's do it.
Yeah.
So,
okay.
Yeah, tell us about your history a little bit. How did you get here? Yeah.
Right. So it's going to be different probably from the rest of you. So I'm familiar with socionics, which is the Russian derivative of Jung's typology. I got into that because I had some friends and some teachers when I was like a kid, like in middle school, who were like really into the Myers-Briggs. And I didn't think it was really a real thing or that important. But like when I have a lot of people around me who really like something, I try my best to like give it a good chance. And I started with the Myers-Briggs, and I would like go to different websites. And this was after I was in middle school. This was like late high school, early college. And I just like, you go to one website, you get like, okay, the types are like this is how you identify them. You go to another website, it's totally different. It just seemed like complete chaos. And I was like, okay, well, this is proof that all of it is bullshit, because no one can agree on anything. And it's just like, you know, you can have your own opinion, but if people aren't agreeing, it's not real. And then at the end of that, when I'd already given up on everything, I found socionics, and they have a more clearly defined terms and a more complicated model. And I got into that, and it seemed clear enough that you could actually, like, I could try it out in my real life and see if it was actually the case. It also had an aspect which I don't think you guys look at much, which is how the types relate to each other. And Augusta, the Lithuanian psychologist and sociologist who made socionics, was not only interested in personality, but also like the chemistry between people, especially like romantic chemistry or like business partnerships, things like this. So a big part of socionics is what's called intertype relations. Like a really good example is if someone is the same type as you, like maybe you have similar interest, or at least you can appreciate the way that they put things in words, but at the same time, you're going to have the same weaknesses. And so if you guys were to partner, you're going to both want to do the same things, and you'll probably get tired of the other person. And then, of course, like you could have people who are very different, but there's different ways of being different. So, so the ability to apply socionics to people to see if it's real, and also this aspect of like romantic chemistry, was enough to get me to spend a lot of time learning and applying the theory. Like at first, I didn't really, again, believe type was a thing. So I was like, well, why can't I just be all the types, or same thing with anyone else? But then when I looked at myself and other people for long enough, I was like, okay, well, they can't be everything. Like they're definitely not this, right? They're definitely not this. And at least in my personal life, like if you get to know someone deeply enough for long enough time, then you can basically eliminate all the types except one, and then that one fits them pretty well, you know, like close enough for a general description, you know, because people of the same type are different. So then I was like, okay, well, maybe this is real. And so I joined some socionic internet communities, and then I saw the same issue I saw with the Myers-Briggs community, which is like people are being typed different things. No one can agree. You have this little clique over here who thinks that they're right and they all agree with each other. And then this totally other clique has totally different opinions, and they're both using the same rationale, which is, well, the people around me agree with me, so I have to be right. And so it's just like, oh my God. I guess like fast forward a little bit, I came to the conclusion that for this to be productive and for us to achieve some sort of union, then we need to start pursuing this more scientifically, which is to say, oh, please don't put me full screen. God damn it. Okay,
There we go.
So, and the reason for that is we need some way of knowing that this is grounded in reality, and it's not just one person who's popular and then everyone agreeing with that person. Also, with internet communities in general, and I think at least socionics is better than average, but you have a lot of people who are trying to steal attention and resources for themselves and not benefit the community. And I was trying to figure out like, okay, well, what would push those kind of people out and bring in the kind of people that I want to relate with? You know, people who are like, you know, high quality people who are doing interesting things with their lives, who aren't complete losers and aren't psychopaths. And I was like, okay, well, trying to get people to do science is a great thing because it's really hard and nobody likes doing it, or most people don't like doing the work. So if we elevate that standard, and then it will push away people who are taking advantage of the community, and it will encourage and the people who are actually trying to contribute. And at first I thought I could like just convince like, okay, well, this is obviously the case, convince everyone to do it for me. But then like, I don't know if you had this experience with your guys' community, but everyone has their own little like pet project.
This is our community. This is our pet project.
Oh, sure. But I mean like an OPS in general, because I think you guys came from there.
Yeah.
Talk
about you.
Yeah. Sure. So I realized, okay, like I can't get other people to do this. I saw this issue. I care at least enough to make an attempt. So this is work that I have to do. I can't get people to do it for me. I originally took a psychometrics class in my undergraduate degree, and then eventually I ended up adding a statistics minor to my degree to try to figure out how to do this. And I think basically a few steps are, first you have to make a mathematical model, because one issue is people are using all these different words, and you know, just because I say a term doesn't mean you're going to interpret it the same way. So mathematics is necessary for science because there is no ambiguity. Like I can write down exactly what I did, exactly how I processed the data, and then my argument, and we're not confused because like I mean extrovert this way and you mean extrovert that way. It's like, okay, what does this mean? But that's just the beginning. Then you have to figure out how can you take the model and find something that you can test. And the basic standard in science is, if it's not falsifiable, it's not scientific, because part of the scientific process is always the feedback with reality. Without that, you're just speculating, and like, maybe, sure, you're doing philosophy, but like, I don't really want to do that. I think that's a waste of time, and it's a good way of just enabling bullshit. And then, of course, like, once we figure this out, then maybe we can give these tools to people to go and actually implement these things, and start taking all the huge pile of work we've built up with all our theories and speculation, and try to go through and see if any of it is coherent. And again, I think maybe I'm a little bit more pessimistic than other people in this call. Like, I definitely, like, I see socionics and typology in general being true, but like, I see all these other people disagreeing. They can't all be right. And it's like, okay, well, why do I think I'm any better than anyone else? I don't.
So Andrew, can I just jump in? So what do you bring to this project? What's your
specialty? Yeah. Okay. So trying to figure out how to put socionics in terms of mathematics. Originally, there were these things called the Riemann
dichotomies. So this is what you were doing before, right? And this is a different project here. But what you were doing before is you were doing group theory with socionics, right?
Yes. So eventually, the conclusion I came to is you need to use group theory, because there's these complicated interactions, and this is the right way of modeling the theory. And not only does this apply to socionics, it applies to any Jungian derivative. So that could be OPS, that could be BYCOGNITION, that could be Myers-Briggs. It's all the same thing. And so, again, I'm still on team socionics, but I feel like all the different Jungian theories are like in it together. Like, if any one succeeds, it kind of validates the field, and then it's good for everyone. And especially the mathematics generalizes across all the different models. So that's mainly why I'm here.
Great.
Awesome.
Thank you. Welcome.
Yeah.
What's up, Rob?
Hey, guys.
I just introduced Rob a little bit. Rob's a really smart guy. I enjoy talking to you. You understand everything really quick. Master's in engineering, electrical engineering, right? Something like that. Yeah.
No, it's so I did bachelor's in mechanical engineering, and then master's I did data science and AI, and right now I'm doing my PhD in AI as well.
Oh, nice.
Yeah. So should I just begin?
Yeah, jump in.
Yeah, go for it.
Yeah. So I got interested in like things related to psychology when I was around 16. That's when I found out like this thing called I don't know what it's called, but basically there are 4 types. The first one is called sanguine, choleric, phlegmatic, and melancholic. And yeah, basically I took this like it was like a thing at school where the teacher just gave you like a bunch of lists, and then you just ticked which one fits you the best. And when I got my type, I felt that, wow, like it really explained what I felt really well. And so that's how I really like got interested into psychology and typology. And so right now I'm very so about 2 years ago I discovered like John Beebe's formulation of like this cognitive functions and all, where they combine Carl Jung's T, F, N, and S with like an orientation of introverted and extroverted. And I felt that that the structure that he created there is very foundational and quite fundamental, because it could be applied in so many different cases. And yeah, so that's what really drove me to be very interested in this type of stuff. And the thing that I've been working on is trying to see, trying to figure out like a way that we could prove that this the existence of these cognitive functions. I think a lot of what we've been doing in the community is also about like how we can combine these cognitive functions that we already have and create like higher level abstractions. But then I also think that it's necessary for us to like show or prove why these like cognitive functions must exist, and it would be nice if we could do it like formally. So yeah, I've been working on that, and I've also been researching about reinforcement learning, and I find that a lot of the concepts that we talk about here has like lots of correlation to what we're doing in the reinforcement learning community. And so yeah, so I've also been trying to find like parallels between these two different fields.
Yeah, awesome.
Nice.
Hi,
Ajit,
so
I've had you on before. It's a pleasure to see you again and have you with us. Yeah, some really good ideas you have going. Did you want to bring up your presentation or just talk generally? We can refer back to also, we did the interview together. But
yeah,
what are you specifically bringing to this group here?
yeah. So I mean, in order to not like be too long, I just kind of show sort of other things that I wasn't able to show in the presentation. But yeah, I'm happy to be back. So a little bit more about me. I did my undergraduate at UIUC and University of Illinois at Urbana-Champaign for computer science and linguistics, and then I got another major in brain and cognitive science. And then right now I'm finishing up my master's in psychological science. Basically, I just work where we study how infants learn language and see if we could apply those sort of those insights into studying how studying language models and different deep learning architectures. But lately, my sort of focus has actually shifted more towards sort of what we're doing, sort of like research adjacent to BYCOGNITION. So I am doing several projects in the Active Inference Institute, which is this institute of, hundreds of sort of researchers who are studying active inference and the free energy principle, which is a computational neuroscience theory of behavior and cognition and perception. And basically under them, I'm trying to that's sort of a way I kind of see of linking BYCOGNITION to academia, of using this sort of formal framework for cognition and behavior and seeing if I can find ways of linking cognitive functions and depth typology into like the active inference framework. So that's kind of what I've just been working on, and using that, there's like several projects that I'm doing, specifically like what I'm kind of calling overall as computational psychodynamics, is seeing if I can actually make applications by connecting active inference and this, and seeing if like, is there a way of like applying this computationally? So,
And you've actually done it.
yes.
Yeah.
So, in my undergrad, I did specialize in like computational linguistics, which is sort of, natural language processing, what you might see with, all the latest sort of language, like language generation and all of these latest advancements with GPT and all that kind of falls under this umbrella category of like AI, but computational linguistics. And in computational linguistics, there's this sort of, it's basically a hierarchical framework, syntactic framework to understand language. Like what I see psychodynamics and what we're doing here at BYCOGNITION is akin to making linguistics, but for behavior and cognition. Because we have these sort of overarching categories where you can kind of lump behaviors into it. And I'm trying to see, well, sort of the approaches that you use in computational linguistics, can I apply that towards modeling behavior and cognition? And that's kind of what I've just been working on. So I can kind of present.
Sure.
I'll just share my screen. So kind of one way of going about this is making sort of, okay, I think this will make it more clear. So I'll start with the diagram of kind of how the generative story worlds work. So first, one more, I would say like kind of like obvious example of why you would want to model behavior in a sort of process-based approach. So like, one sort of aspect, like why can't we use like Big Five or something like that? Why would BYCOGNITION be more useful for that? So having these hierarchical overarching categories where you can lump behaviors into makes it so you can actually categorize individual behaviors over time. So this allows you to model the personality or how a character transitions between behaviors just by using sort of discrete like observations of behaviors over time, like what actions they do over time. And kind of going back to why I was bringing up computational linguistics, adding in sort of this additional information is actually a common technique when you're doing sort of large, like when you're using, when you're creating language models or creating different sort of NLP tasks, you want to encode this additional information. So that's basically what I'm doing. I'm sort of encoding the BYCOGNITION or encoding like sort of cognitive functions like, the animals from OPS, for example, is a perfect example. And in BYCOGNITION, we call them like cognitive vectors. So just encoding this additional information in allows me to control the personalities of the characters and also create observational based psychometrics, which I'll go into next. But basically, you have sort of your characters, and then I just use language models to predict next sets of events, and then use transition matrices from Markov models. And you could use different sort of approaches for this, but basically it just predicts what animal state what animal state or behavior state each character will be in at a given time in the story. And using this approach to like make this more concise, basically all I have to do is have my characters and put in their sort of personality type. To be clear, BPSC is not exactly the same as what you would think in OPS, and I'll go into what it actually means. But basically, I just enter in a context, and then it uses this sort of process in the back end to keep generating next events and cohesively tying it into the story. And you could do different personality types and see how the different personalities actually interact. And here you can see I was experimenting with changing the personality halfway through the story.
Yeah, in the end, you get a narrative, and you get interactions within the narrative, contributions to the narrative. Yeah,
and all this is kind of like you can kind of see like it's mostly modeling how a character transitions between these behavior states, and you can kind of see how I formalize each of these personality types. I need to come up with better names because the BPSC already exists, but basically you can kind of see how these are the actual personality like values that I hard coded for the personalities. But that's cool. Like narrative generation is cool, and I'm gonna host this sort of user interface for people to interact with and play with and use their own characters and try it for themselves. But basically, that's one aspect of how you could actually apply this. The other aspect, which I've kind of been focusing on more lately, is how do you type someone just by observing their behaviors over time? So I have sort of a flow chart here explaining kind of like you have your observations, and then we use something called prototypical networks to find like how similar a behavior state is to the observed behavior. and then we annotate the behavior state, and then we train the transition matrices, and then we can conduct various analyses and applications using this. So some of the applications that we could do is we can calculate the stationary distribution. So you could just observe someone's behaviors over time, and then you can evaluate their long-term behavioral tendencies using this approach. And then you can cluster the behavior states and then do behavioral sequence analysis. And like I showed with the generative story models, simulations, you can compare the different behavioral dynamics between individuals or groups. You can calculate absorption probabilities. So like some states more likely than others for you to just like stay in, or is there like a specific behavior state that people just kind of tend towards? And this is different ways of formalizing like how we can use this as a psychometric. And then you can calculate sort of how predictable their transitions are, and then like how likely it is in temporally for them to transition between behavior states. So that's one aspect. And then one thing I've just been working on in this manuscript I've been working on for a really long time. It seems like every time I kind of get close, I get more sort of feedback and I have to keep updating. Basically here, I introduced BYCOG and sort of how we define entropy using existing theories in cognitive science. So like radical plasticity theory, and sort of how we kind of formalize this with self-attention mechanisms, Markov blankets, and semantic networks. And then what I think is like most interesting is kind of getting towards a formalization of how we actually prove this, because active inference, and I'll touch a little bit on this, I know this is running a little bit long, but basically we can kind of create equations for each of the animals using the active inference framework. And then also how we could define like single deciders and single observers using active inference, as well as something I'm sort of still working on a little bit, but the different axes, like intuitive versus sensory axis, as well as the T versus F axis. And that's something I'm trying to formalize using the active inference ontology. And if you want to check out the active inference ontology, I encourage you to go to the active inference ontology website, because sort of one of the goals I'm trying to do is making it so we can connect all of these definitions. And this is a really good way, I think, of getting ourselves into academia. And then other than that, I think like I'm just working on sort of like extending this to make a more formal like dynamic cognitive vector theory. And yeah, like active inference is very interesting. I think like I'm finishing up, but basically, well, one, with AI, we have like new ways of collecting data. So observations of behaviors will become a data set that we'll probably be using at some point. And active inference itself shows it's a computational neuroscience theory, and it's was actually used to do like use brain cells in a petri dish to simulate the game of Pong. And it was able to do this in 5 minutes because it's able to process information in an analog way. Like instead of using digital compute, you could just use actual just like brain cells in a petri dish. And all of this is kind of related to like the free energy principle. So I personally think sort of future directions wise, where BYCOG will be eventually heading is, you know, combining personality theories and observations of behaviors with theories in computational neuroscience. And, you know, eventually I kind of want to bring this towards like how we actually sort of might want to curriculum learn models that get information from what people are visualizing or imagining and recreating it, and maybe like other aspects of interfacing with the brain and behavior, like using observations of behavior to get information about the brain and seeing if we can actually utilize that to improve sort of brain-computer interfaces and different things like that. So.
One of the things I really liked looking through your paper as well was just the use of the language, how the language is very natural for academia.
Yeah.
It doesn't even sound like you're speaking a different language, because a lot of the time in typology, you have to learn the lingo. Here, like the language that we're using, it's just intuitively right. You get what you're trying to talk about without even having to define your terms. Yeah.
I agree. And I think like, eventually the people in the Active Inference Institute are actually pretty excited about this, and they actually see a lot of sort of connections with Jungian psych and sort of theories, modern theories in computational neuroscience and biophysics principles. So it's just like very interesting, and I think there's a lot of promise here.
Nice.
Yeah, awesome.
Okay, Jacob, do you want to take it away? What do we? If people want to get involved, can they get involved? What are you planning on doing?
Yeah, I thought, Rook, did you have some slides you wanted to show still? I think you had I don't know if you mentioned diagram. Sorry, Rom.
You're muted. Oh.
You're currently muted.
Sure.
Yeah, awesome.
Oh, nice.
Bring him up to the front line, Benjamin.
Trying.
So I think I uploaded the slides, but do you see it?
No, you gotta there's a present button at the bottom.
Okay. Then I gotta share the screen, right?
Yeah.
Okay. Give me a second. Okay, can you guys see the slide?
Yep.
Okay, so I thought we all are gonna talk about like what we've been working on in more detail. So that's why I made like a slide. But basically, I wanted to talk about
Perfect.
the uncertainty principle and its relation to nature and also cognitive functions. And a lot of the concepts here, like relating entropy to cognitive functions and all, I got it from Benjamin. So credit where credit is due. So first of all, I want to talk about the uncertainty principle, right? So one example where we can observe this principle is that, like, for example, we have this image of like people on a roller coaster, but we can definitely tell that they're going pretty fast. But then the problem is that we can't be infinitely certain of both an object's position and velocity. So what do I mean by this? So like so we kind of know that, okay, the like the first card is probably over here. Wait, do you see my mouse as well, or?
Yeah.
Okay, great. So you kind of can tell that, okay, the position is probably here, but then we see this trail as well. So like we're not 100% sure if it's exactly here. Another thing is that like about the velocity. Like you can see that it's moving fast, but how fast is it moving? We don't know. And so, for example, we wanted to know the position exactly. What we would have to do is like we would have to record like a video or like have like an extremely long exposure camera. So you take a picture of something and it's exposed to the light for a very long time. And if the object is like still, then you can actually be very certain about where exactly the position is. However, by doing that, like you mess up all the information about the velocity because you're trying to average out all the information about the velocity, right? So this is what the uncertainty principle is. But how does this even relate to like cognitive functions? Is what I'm gonna talk about next. So similar to like the example I just talked about just now, where the comparison is between the position of something and the velocity of something, we can see that sensory and the patterns within the sensory also cannot be simultaneously extremely certain. So for one example so this is just like a bunch of diagrams, but so let's say that we have a bunch of sensory points, right? The more sensory points we have, the more we can sort of see like, okay, the pattern is like this arrow is like the pattern, right? And the more data points you have, the more certain you can be of the pattern here. Whereas if, however, you might not exactly be certain of all these data points. You can be like, oh, maybe it's here, maybe it's here. I don't know, but like the main pattern is like it's going upwards in this way. On the other hand, you can be certain about like the sensory, like, okay, this is exactly what happened. This is exactly what happened. This is the sensory. This is the sensory. But what's the pattern? I'm not sure. Maybe it goes like this, or maybe backwards. I don't know. So this is just an example. But like, so like in the first one, you can say it's like we have a bunch of these sensory that happened, and so this must be the pattern. And whereas the second one, we're more sure of the sensory. So like these are the sensory I'm sure of, but what's the pattern? Okay, so we can kind of see that like even in the abstract sense of what sensory and intuition is, this pattern of uncertainty principle is there, where the more certain you are of like the sensory, the less certain you are of the intuition part, and vice versa. Okay. So now I would like to talk about what is called the Gabor limit in the uncertainty principle. So basically the limit of the combined uncertainty of intuition and sensory is called the Gabor limit. But even though I say the intuition and sensory, actually what they mean is that given some sort of signal, like a time domain signal, you can always convert it into something called the frequency domain. So you can take the frequency contents of the time domain signal, okay? And so my analogy here, again, is that the time domain signal is something like the sensory. It's like the actual data that you saw. And then the frequency domain signal is like the intuition. It's the pattern within the data, right? The frequency gives us information about the pattern. And what's really interesting is that the uncertainty of these two things have a limit where they have to be greater than or equal to this equation, like 1/4 pi or something like that. Okay, so if we actually like sort of write that in another type of diagram, we have this thing called the Gabor limit, and this y-axis is basically like the uncertainty or the certainty level, your combined certainty level of like both n and s, or it can also be t or f, right? So if you're above this Gabor limit, which gives you the optimal balance of like how uncertain you can be about one part, one domain, and how certain you can be about the other domain, we have this optimal balance. But you can actually experience things with your intuition and sensory with higher, uncertainty than what's optimal, which means that you'll be less confident than what's possible, or you can actually also be overconfident. So even though like in reality, the patterns or the sensory that you're constructing to how do I say that you're summarizing, let's say, should not be like or okay, the better word is generalizing. Let's say you're trying to generalize something, but you only observed a few information, but you're very confident about this generalization. This means that you're way below what the Gabor limit is, and so you're overconfident. Okay, so now
can you go back there for a second? So I think one thing people might have missed is if both of these circles were really close together, they would approach the Gabor limit, but because one of them is moving down, the other one has to move up. Because when you multiply them together, right?
Yeah. Actually, what I was writing is this is like two different people. So red is like person A, blue is person B. So the dots kind of.
It would also work for intuition and sensory. If one was intuition, the other one was sensory. You could.
Yeah. We can have like two dots that sums or multiplies into a single dot too, right? But yeah, in this diagram, what I was trying to what I meant when I drew it is that one circle represents like the combined one. So like it can be like this product here. Okay, so
well, because then you can't have anything lower than the Gabor limit. It always has to be above the Gabor limit. But then here you've got one
you
that's
can be you can actually be lower. Like what you
provided
perceive.
that the other side is higher.
No. So
No,
what I mean
the
here,
Gabor limit is
No,
more representing like the limit of the possibility.
yeah,
Is there?
yeah, the possibility is there, but then what you perceive, what you think can be lower. So you can be more confident than what naturally allows you to be confident, right? So given the data that you've seen, let's say like given the SE that you've taken in, if you form an NI that is overconfident in your brain, then I mean, like if you form like a generalization that is more that makes claims greater than what you've actually seen, then you're probably below the Gabor limit, where like actually you have the real generalization that you can make, the real level of generalization you can make is at the Gabor limit. Do you get what I mean?
So delusional.
Yeah, basically. You're overconfident, delusional. Yeah. So, you can think of like the cognitive orientation, like like the extroverted and introverted part of your cognitive functions as some force that pushes, that dot right in the previous slide upwards or downwards. So usually like an extroverted function would like to push the combined uncertainty upwards, whereas the introverted function would like to pull it downwards. Okay, so that's why having a good balance between your introverted and extroverted function is crucial, so that like that thing is close to this optimal balance where the Gabor limit is. Okay, and now an example of that is like when you have a tidal wave. Let's say you're like an EP type, so you're doing a lot of SE or NE, right? And you're kind of neglecting your NI or SI. Then you're going to be very uncertain about things. And what happens is that you're going to be too uncertain. Even though you've collected so much information, you're not summarizing that at all. You're not putting them in like a form that you can actually actively use. So like the level of where your combined uncertainty is going to be way above what the optimal balance is. And so basically reality will force you to use your like introverted function and say, hey, okay, come back down here. Try to like summarize what you've been doing so far. Okay, so that would be like a tidal wave. On the other hand, if this dot here was like very low here, right? It means that you're way too overconfident. You're overusing your introverted function. Again, the reality will hit you because the reality will say, okay, what your generalization or summary should be much less confident than what you think it is. And so reality is going to hit you and it's going to try to push that back up by forcing you to use your extroverted function. So, okay, so this is kind of helpful because it kind of tells us that, okay, like these cognitive axes, they must exist, because if you're only using a single cognitive function, it's going to be dysfunctional because it'll push or pull this certain combined certainty levels too far from the Gabor limit, right? Yeah, so therefore they must come in pairs that oppose each other, therefore forming the cognitive axes. So yeah, so everything I said so far is, I guess it's kind of interesting, but then it really lies on this assumption that this cognitive functions could be modeled as something called a Hermitian operator, and that the pairs in an axis are another math jargon. It's called incompatible with one another. So if so, these are very like formal things, but if we can sort of model cognitive functions, if we can define them in a way where it has these properties of being like a Hermitian operator and that they're incompatible, I believe that it will really help this field moving forward, as people will be even more convinced. And there's going to be like a very clear definition of what these cognitive functions actually do. Yeah, so that's basically what I wanted to share for today.
Well done. Thank you.
Thank you. Cool. I reckon we should do a little bit of discussion. Any questions people have, and then we'll close out.
There's a question for you, actually, Loglin, if you want to bring it up.
Yeah, go for it. By N. Riley, or is there a group on Discord?
Yeah.
Oh, yeah. Okay. Yes, we do have a group on Discord. If you want to find more information, hunt down me or Benjamin. Benjamin, what's your Discord username? Is it just Benjamin?
I mean, we could put a link somewhere.
Can we put a link?
Can we? I don't know. Do you want
I'll
to?
see how quickly I can. Yeah. Why not? I'll see how quickly I can get something for a link. You guys keep chatting.
All right. Andrew, did you have a question that you seem to have something to say?
Yeah. So let me just make sure I understand. So because you can't have these two things at the same time, you have to choose one or the other, and that creates the spectrum. And then on that spectrum, is there like an adaptive landscape where maybe like the middle is the best, and the farther away from the middle you get, then the less fit your behavior is? Or is it like maybe doing the middle, you're not really benefiting from either extreme, and it's better to be up here or here. But if you go too far, then you're too extreme. And so maybe this would motivate, there's like a general average of humanity, and then some people are really high, really low. That'd be the first case. Or maybe two specific types where it's better to focus on one strategy or the other and not do both, because it takes more energy, or it has some sort of cost. So I'm curious about, have you thought about the adaptive landscape over these spectrums?
So I guess like in terms of the strategy, what the Gabor limit tells us is like, it doesn't tell us about how much information you have gathered and all. So what I mean by this is that, let's say you gather just like a very, very few data points, but you also make very few general assumptions about it. So you would probably be very close to the this Gabor limit, right? Where it is optimal, right? But then it doesn't mean that you actually learned a lot of things. It just means that you're at the optimal optimal point where based on what you've already observed. So I believe that like these different strategies are helpful. Where, for example, if like in research, if you have very high entropy and like you really explore a lot of different things, and then even though you're not really doing introverted functions much, like you have already explored so much. So when you have to do the introverted function, it's going to be a lot of work. But then what you can, like if you can pull that combined uncertainty down to a level that's close to the Gabor limit, the amount of information that you have summarized is much more than someone who didn't really explore much, but also made like a perfect type of generalization from the data that they have observed. So yeah, I guess there are like different strategies, but the Gabor limit itself does not say like which strategy is better. It just describes like what is the limit at the optimal balance of like generalization versus exploration, I guess, that you can have.
Okay, so does that mean that there's one optimal place?
Yeah.
Okay.
It's like it's like this mathematical thing where like there's a specific value that it must be that you can compute. Like it's called the Gabor limit. You can search it up.
Yeah, I'll look into it. Thanks.
But right, one thing I have to say is that this obviously, the Gabor limit, it sort of acts on how do I say? It's like we're talking about frequency domain versus time domain of signals, right? But then there's many types of ways we can interpret a signal, and it doesn't have to be the frequency versus time domain. It can be something else. And so we don't know anything about this yet. So we don't yet know the exact number or the exact type of limit we have to use, because there's actually many different types of limit depending on what you want to use. Like you can use, the variance of the signal, you can use the entropy of the signal. These things have different limits. So we don't know which exact formulation it is yet, but I think the general idea is still important, that like we have this optimal balance and we want to, like the cognitive functions try to balance our position in this balance.
Great.
And I have another question for Ajit. But feel free, if someone else has a question, you should go first. So my question.
Maybe before you go, there's a question from the audience. Depending on the context, there is a different optimal limit. Okay.
I think that's the answer to what he
right. He's summarizing
asked,
for
right?
you. Yeah.
Yeah.
All right. Go ahead.
Okay. So since you're familiar with active inference, I'm sure you've heard of Carl Friston.
Yep.
That guy's a legend. I love him. So do you think that you could use Markov boundaries and blankets to make a hierarchical typology where like maybe like more specific concepts are the Markov boundaries that are irreducible, but then like collections of these can make these larger categories? And then this would be a way of empirically testing such a complicated hierarchical model as typology.
So like more specific concepts would be the boundary. What do you mean by specific?
Yeah, no, like the more specific would be the blanket, and then the more general would be the blanket, the more specific would be the boundary. So maybe the blanket would be introversion and extroversion, and then more specifics would be like the specific kind of introversion and extroversion.
Yeah, I mean, I think like the Markov blanket is like a very interesting tool. I've only seen it really sort of used in the case of defining why agents do the free energy principle. So kind of just like the separation between like subjective and I guess that's what you're saying, introversion and extroversion.
Well, yeah, and also like with a theory, any typology theory, then a lot of people like to try different combinations. And it's on one side, you could combine these two things and then try to describe what that new group is. But I have a sinking suspicion that some of those combinations are more real than others. And if you're trying to decide that empirically, then you could do something like a Markov blanket to see if that whole collection or that way of combining things add something to the whole theory or not. Even if like mathematically you could move sets around and do this, I was thinking, and it would also be a way of doing it hierarchically, where it's like you could be looking at these really specific, complicated metrics, or also these very like broad metrics, and it would be nested. Kind of like with like the neuroscience, you could be looking at a single neuron. You could be looking at like the region the neuron is in, or the brain region, or the whole brain. And I think you could model that with Markov blankets. So could you do something like that with typology?
I mean, I don't see why you couldn't. It would be very interesting to see. I haven't really thought about that much, of using like a Markov blanket to model typology.
Okay.
But
cool.
Yeah.
Well, thank you.
Yeah, and I also had a question for Ram. Like, I feel like in active inference, we're able to sort of model, like when I was trying to work on like the like N and S axis, I can kind of model why there would be sort of something like the Gabor limit for intuition and sensory, because in the sort of divergence term for the free energy equation, increasing certainty only about one, specifically like only about sort of your intuition or like sort of your beliefs, without increasing certainty in the sensory observation leads to higher free energy, and also vice versa.
Okay. Yeah.
So you can kind of model why the intuitive sensory axis is, the way it is. And I actually was building off of what you told me a while back about the Hermitian operators for it. But when it comes to the T and F axis, I've had a lot more trouble trying to figure out how you would actually model that in the active inference framework. As far as I could tell, from where I got, it was just I can model why TI is paired with FE and why FI is paired with TE, but I can't model why the T and F axis, or I haven't been able to model why the T and F axis exists yet using that framework.
I think we all are still trying to find out what exactly defines T, what exactly defines F. One thing I remember you telling me is for example, Fi is kind of the kind of summarizes the TE in a sense. Okay, we have all these reasons, and so that's why I value this thing this much. So it's sort of like a summary, and in that sense, F is kind of similar to being a summary for T, right? So which is the same thing as N being a summary of S, right? So I do see these patterns, but then I'm also still struggling to find the exact way we can phrase it so that it universally makes sense. So I'm still figuring out how we could differentiate and also formulate these T and F axes, both in the active inference and also in the sense of uncertainty principle and all.
Yeah, it's definitely a challenge, but I think we're heading in the right direction.
Right. And I actually have some comments about the Markov blanket stuff. From what I understand, there are states, these Markov blanket nodes or states, whatever, where if you know the probability distribution of them, then there are two different, let's say domains, and there's this thing in the middle where, so if you know what the value of this thing in the middle is, you kind of can tell the distribution of what the other two ones are, right? So okay, even though we have these two things, let's say one is one observation you found, one behavior you found, this is another behavior, and they seem to be correlating, but then so let's say some action happened in one space, then we can map it that okay, if this action happened, then the probability of this other type of action happening is this much and all. But then if let's say we have this node in the middle, if we know this node in the middle, then we don't have to know what happened in one space to know the other space. We can directly map the value of this node in the middle to the probability distribution of the next of one behavior field or something. So this, you can think of this as let's say you have the cognitive function stack of someone, so you can think of that as this node in the middle. So given that this the cognitive stack of one person, you kind of can tell the probability distribution of the certain type of actions that they're gonna do, without having to know the other type of actions that would actually usually correlate to this action or action that you're trying to model. So
I actually have a diagram of that.
Oh, okay, cool. Could you share that?
I sent it in the mechanics chat in the server. Let's see if I can get the link.
Do you want to share it? I'll pop it up.
There's the link. You open that up in a minute?
Do you want to present it on the...
Yeah, one sec.
Yeah. Yeah. So what I was trying to say about the Gabor limit earlier, while you're just bringing this up, is that it's a combined limit. So if you're really, really certain in one domain, then the other domain would have a huge uncertainty, and they would multiply together to be above the Gabor limit. And so,
yeah, the reality is like that. Yes.
right.
Like
And
what's
so then,
possible. Yeah.
right. And so then if you were overconfident in one, that means you would have to be underconfident in the other. And that's kind of what I was pulling up from your diagram.
Yeah. Yeah. Like to be at the Gabor limit, then you have to do that.
Right. Yeah, I had this old video about that too. I don't know if you saw it a while back.
Yeah, I think I saw. You talked about the uncertainty principle too, right? But I forgot exactly what you talked about. But yeah, I did watch that
same thing,
video.
intuition, sensory, and yeah.
Ah, okay.
Introverted versus extroverted as well.
Right. Maybe I got some of the ideas from there. Like I watch a bunch of videos and like I forget like where I get these ideas from.
Yeah, I was more looking at the Fourier transform as a basis, not really. Okay, here I see it, Jacob. Yeah.
Yep. Cool. So I made this. Essentially, I made it in Google Sheets. So when you modify the values in these squares, these represent the transition between this one's known to tribe, so that forms direct. But then also the other side is from tribe to known. So looking at this, it's like there and here. So it's showing the transitions between different things. So what I made this for was because this both shows how you get deciders and observers, while also showing how you can get, in OPS they call them jumpers or even glass lizards. So how you can have a decider and an observer in a Markov chain model. So by changing the different, everyone would have different variables in each of these that could be randomized from 0 to 1. And if you randomize them, it would give you a type, the best fit label for that. Does that connect much to what you're doing, Ajith?
Sorry, could you repeat that?
Yeah, so I made this. This is a diagram which is showing essentially it has both the animals and the demands.
Do all the values add up to 1, or they're just randomized?
All these values, did I add that? I think you can do, do they add up to 1? Okay, I think it works this way. So these, no, I don't think they do add up to 1. I think you just randomize them, is what I remember. Maybe?
Okay, then you would normalize them afterwards to get them to add up to 1?
Yeah, because it's all probabilistic to some extent.
Okay.
Over here. Or maybe they do add up to 1. Something adds up to 1. Oh, yeah, like this. That adds up to 1. That adds up to 1. This adds to 1. That adds up to 1. So, yeah, so known's probability of... it has to add up to 1. Yeah, known's probability of transitioning to tribe to known or to itself adds up to 1. Which is represented here. And then I've run instances of it, which calculates approximately what the... so this one, this current diagram represents someone who would be an EJ, who's also in OPS blast last, or here direct last. And so that gives you a Markov chain model of that type.
Yeah, I mean, that's pretty similar. So is known, so it's transitioning between, it's transitioning between the animal states, right?
Yeah. By transitioning between the functions or the modules, it brings about the transition between the animals / demands.
Yeah, I would
It's
say
just it's not a transition though. It's like a probability distribution. It's not like 1, 2, 3, 4, that kind of thing.
Well, it's transition probabilities, right?
Right.
I mean,
Yeah.
Okay. Yeah, that's pretty much like, I would say, it's like one part of sort of the approach I'm trying to do with the psychometrics, where we're trying to model the transitions between the animal states. I would say like the only other additional aspect would just be how we map the similarity between one of the animal states and an observation of a behavior. And if we do that, we can train these transition probabilities and actually use them as a psychometric.
Yeah. Cool.
Yeah.
Is there any more questions?
Yeah, one here. Does anyone know who cognitive typology is? Johan Sandoval?
I do. I have looked into his work. I found interesting. What was my thoughts on it? I think he's done really good foundation work. My only issue is with the process of typing. I don't think you can get I think it's weird. I think it's all good and accurate. I think the way of getting the types, I don't think works perfectly with just mainly I don't know, what would you call it, animatronics of the body, I guess.
Yeah, I'm interested in see how like they take into account individual differences like between people and how they, some people might have like different sort of facial expressions or anything to certain, I don't know, functions. Like people act differently. But
yeah, I found the the thing that becomes usable after knowing the type difference between OPS and what's it called, cognitive typology. I found that the coming from the OPS type brings something that's a lot more usable and coherent at the end, rather than I found some cognitive type people, it's like, okay, well, I don't know what, now that I have this type of the person, I don't know, like it doesn't have as much usability at that point, I found. Cool. Any more questions?
So, I have one of you, Jacob. And
Fire
this
away.
might be one that you have to get back with me because it's pretty deep and like it took me a long time to figure out my answer. But you said that you want to pursue a more scientific direction for typology. And if you agree that the definition of a scientific theory is one that is falsifiable, I want to know, how is the work you're doing falsifiable?
We're here together, buddy.
Oh, yeah.
How is it falsifiable? I would say we'll find out. Well, that's the whole point, right? Like,
well, how?
We're going to test it.
How?
How? I think we haven't gotten there yet. At the moment, the foundation need to have, like, what are we falsifying? I think is what we're doing at the moment. Well, that's what the framework is. What is the thing we're actually going to try to prove or falsify? So getting that somewhere, and then attempting to do that. How could that be done? I've had a couple ideas. I don't remember them off the top of my head, but we'll try to think that.
This is a super hard question, and I think everyone I've ever asked, they're not quite sure. But again, like if you agree with like Popper's definition of science, that is science. It's not like you can be more formal. Like I think the socionics people, a good thing and a bad thing about them is like they were very rigorous about making things formal. I think that set the stage, but like it itself is not scientific. So I would never say
I agree
scientific
completely.
right now. It's pseudoscience. And
Definitely.
that doesn't mean that it's wrong necessarily. It just means that we have to do the work to make it scientific.
I think Ajit has an answer, right?
Well, I was just wanting clarification. So are we just saying like falsifying BYCOG as a whole, or like which aspect of the work?
The anything that would be related to the typology.
Okay.
Yeah. So like why is these types even real?
Yeah.
How do we know? How do we know that the way that we're assessing them is correct and we're not just projecting our assumptions onto an ambiguous situation and then getting a bunch of people to agree with us?
Yeah. So I guess like that is a question I have to contend with like trying to get this into academia. And I guess like the approach I've been kind of going with is seeing like what's already out there, what I can already connect it to, and I guess like latching it on to piggybacking
Well,
like
then how
theory, active inference, cybernetic fulfillment theory. So there's already all of these sort of theories out there. But then the question is, okay, what makes typology and what we're doing useful if all of these theories already exist and explain a lot of the sort of different,
Yeah, you're doing the more externalizing approach, Ajit. You're building something that's going to be used, and then you're testing it against does it fulfill the criteria you want it to fulfill, and then right, that's one way to falsify it. And I think what Andrew's pointing at is more an internalizing way to falsify things, more a way to make sure it's consistent with observation and.
Well,
at the end of the day, you want to take both of those approaches and make sure that they match. Yeah,
that makes sense.
Yeah, well, and it's an open question. So if you guys come up with a method, it's like, this is my hypothesis. There's a bunch of
different tests you can do. Like, I mean, cognitive psychology today is doing a lot of falsifiable stuff with specific coins that they're not even aware that they're coins in Jungian typology yet. But like the beauty of Jungian typology is you can always divide populations into two, even without the full cognitive function. You can go introverted versus extroverts, intuitives versus sensors, right? It's not a full cognitive function. It's just partial, right? And so like a lot of cognitive psychology is doing that because, okay, let's just take this dichotomy and then test these people versus these people and see that there's a statistical difference between whatever behavior we're trying to get them to do. So I don't know, you can check sensors with how quickly do they count versus intuitives.
Yeah. I got to try that one.
Right. But like you can also make predictions based on models as well. And that's kind of, I think, more
as a way to prove it.
Right. What Ajit is doing. So it's not necessarily falsifiable, but it's making predictions and seeing if they come true or not.
Yeah. And I want to emphasize that like falsifiability is an essential piece of this, but then there's all these other things that have to happen to support that. So the other things are good too, but like this has to be there for it to be scientific.
Yeah. Yeah, one of the things I was putting together in the structurizations is they really talk about some kind of neural structure that's happening, and so I would suggest, based on whatever quadra you're in, your brain would look very different because you're actually structuring the neurons in a very different way. And so, I mean, you could statistically group people off based on their quadra and look at their brains and see that there's actual physical structures in the brain that should be different. And that would also be a way. Yeah.
Right. So like, let's say you did this and like there was a tendency, like, let's say you even found like 4 like default mode networks or 4 set points or whatever in the brain. Once you found that, why not just leave typology behind and then just go with this statistical correlation you found from neuroscience? Like typology was the inspiration to look in that direction, but then once you have the empirical data, leave the theory.
Because the empirical data doesn't predict anything. It just tells you what is. It doesn't tell you what it even means. It doesn't tell you how the person thinks different. None of that. It'll just tell you that this is real to some degree. And then after that, you have to sort of figure that part out.
Yeah, you need both sides. Kind of similar to what Ron was displaying with the optimal point. If you're going too far up to the details, you lose the utility of the meaning.
Yeah, and there's like lots of different use cases for like a rationalist schema, like what typology is. Like there's a use case for a schema, just like there's a use case for having parts of speech, like having a definition for parts of speech, like verbs and nouns. Even though like a verb is many different types of words and actions, and sometimes like a word might not actually be a verb, and it might not like completely one-to-one match sometimes, depending on how it's used. But we still use those categories for a lot of different applications.
Yeah, that's a good angle too, because at the end of the day, it's not falsifiable the way you can categorize things. You can always categorize them in whatever way you want. And the categories themselves have use and meaning. There's nothing falsifiable or provable about categories. It's just the way you choose to group things. And that in itself has a lot of power.
So would you say that would be true of the big 5 categories?
Yeah.
Okay, I beg to differ. I thought the whole point of the big 5 is a data-driven way of categorization itself.
Yeah, it's how you categorize, right? Big 5 is categorizing in a very different way than Enneagram, for example. But they're all, if you're consistent about how you're dividing things up, so then within that category you should have some certain correlation.
I think the word true is also an issue word, as in like true, I imagine means 100% certain that is how it is. And I think there's very little that we know that is true by that definition. Even that's very well explored by science. Nothing's reached true status.
So, okay, sorry, Benjamin. So going back to the big 5 and the factor analysis, are you saying the factor analysis method is the thing that is sort of arbitrary? Like once you choose you're going to use that method, then it produces the big 5. But you're saying the factor analysis is the thing that's like the way of categorization itself. Is that right?
Right. Yeah. So the big 5 has a specific criteria on how you categorize. It's very rigid on the categorization methodology. Right.
That's why it's good for self-report, and that's why it's good for self-report. But I think like what we're doing is almost like an ecological approach to personality, and that allows us to do like observational methodologies instead of relying on self-report. And there are some other benefits, like with Big 5, it doesn't generalize to populations that don't live in certain urban environments, like tribes and like uncontacted tribes. Like you wouldn't really be able to use Big 5 as like a valid psychometric. Like there's been studies showing that it doesn't generalize to certain populations, but also like animals and other sort of, it's very anthropomorphic. So what we're kind of doing, I guess, it's like not really tied, like you can use it to describe personalities for babies and animals and even AI, and like we can use these observational methodologies. So I think it's a complement to Big 5. I don't think Big 5 is inherently bad or something that shouldn't.
Yeah, it's just a taxonomy. There's different ways to make group things. Yeah. So I'd like to answer this question. I don't know if anyone else wants to answer that.
Yeah, go for it.
All right. So 3 most important coins. So what we found from the spatial definitions of the cognitive functions, that there's 35 different possible coins, but 7 of them are significant. It doesn't matter which 7, but the 7 that we picked are the ones that sort of line up with Jung's 7. He didn't pick 7. He took whatever. I don't want to get into that, but you could take any 3, not any 3, but you could choose 3 of those 7, and it would be a complete typology. And you can use that in order to define the functions. So just at random, we can take 3, and that would define the full space. We could take introverted, extroverted. We could take implicit, explicit, and then we can take
observer, decider.
Sure, something like that. Yeah, observer, decider, and then you've got a complete typology. So any 3 of those 7. So yeah, it's worth investigating all 7, I think.
Why not all 35, Benjamin?
Why don't you tell us that one? That's a good question, Long.
Why not all 35? Because I reckon to some extent it's good to look at. We're going to be looking at all of them. We've picked, some of them seem to be more already explored, and so why do completely new ones? And some of them are already more built. Okay, to begin, we'll just to get this foundation beginning. Let's do what we can without overexposing and researching them all. Okay, let's do some of them to test, and then we can go back and do more in the future.
I think a lot of them too have very difficult patterns to try to find between.
Yeah, difficult because they haven't been done before. As in, if they were the ones that were started with, they would be easy, and the ones we have now would be hard. That makes sense?
Sure. I would like to say not all any is equal. Like introverted, extroverted, for example, that's a coin that's really strong because it relates to entropy. So like, I don't know if we take that as a given coin, right? Introverted versus extroverted as a given coin, then that already limits the amount of other coins we can take.
Yes.
Right. All right. Well,
Yeah.
do you want to summarize? What can we expect to see? Yeah.
Yeah. So, as you saw, this is some of the people working on the BYCOGNITION project. What we've been working on, all in different directions individually, but then coming together. What we're collectively going towards, and getting this foundation and mechanics and academia, and how we're taking those steps. Yeah. I believe Benjamin chucked the Discord link into the chat, so you can check that out. What we're going to be working about, is continuing to do those steps we talked about before. In the future, we'll probably do another video, something or other. We've made lots of progress and presenting more stuff. So excited to share that then.
Yeah, and I will put that link in the description. I just can't do it now while we're live.
Yep, sounds good.
All right, thanks,
Cool.
guys. Any final thoughts from anybody? Nope. All right, appreciate it. And there's a lot more guys on our team, so
yeah, come join and check them out.
Yep. All right. Later, guys.
See ya. We did it.